logical instructions of 8051 microcontroller. Okay, the logical instructions of 8051 microcontroller. So what are all the logical instructions? Okay, so we have two types of logical instructions, namely byte and bit type of logical instructions. Byte and bit type of logical instructions. So byte, you know, it is a combination of 8-bit. Bit, either it will be 0 or 1. In the previous class, we have discussed we have discussed data transfer instructions of 8051, arithmetic instructions of 8051, whereas data transfer instructions are move external, move code memory access, push, pop and exchange instructions. Whereas arithmetic instructions are add, subtraction, addition, multiplication, division and decimal adjust accumulator. Okay. In addition and subtraction, the flags that are affected are carry, auxiliary carry and overflow flag. Whereas in multiplication and division, carry and the overflow flag will be affected. Okay. In data transfer instructions, none of the flags will be affected except for the fact that if we need to access the RAM memory of 8051, we'll be using the PSW's register select bits for using particular register banks of 8051. And coming to the logical instructions, as I said earlier, we have two types of logical instructions. One is bit type of logical instruction and another one is byte type of logical instruction. So Boolean operators are the basic Boolean operators. Boolean operators are, because logical instructions operates with bits, okay, on the bits, either 0 or 1, basically the binary ones. So what are all the Boolean operators that we know? Here, what are all the Boolean operator that is existing as instruction in 8051 are AND, OR, XOR and NOT. Okay. And other than this, we have rotate instructions also. Rotate, RL stands for rotate left, RLC stands for rotate left through carry, RR stands for rotate right through carry and RRC stands for RRC stands for rotate right through carry and simply RR stands for rotate right. I'm sorry. And swap is for swapping the lower nibble and the higher nibble of the accumulator, because the swap instruction will always be associated with the accumulator. The default register of the accumulator. Okay. So this is your about your logical instructions. And where this bit addressable logical instructions are used. So these are useful for the bit addressable memory locations of the RAM memory, that I hope you know. From 20 to 2F, the 16 bytes of memory locations are bit accessible and addressable, meaning each bit of memory was given a address and you can access each individual bits and you can even change the data. Okay, how we can change the data? Only by using bit manipulation instructions. Okay, bit manipulation instruction that is available in the logical instruction. So from 20 to 2F consecutive lines, each bit of the consecutive lines of the RAM memory, each bit locations are bit accessible. Similarly, the special function registers, and I hope you remember, the special function registers are also given 8-bit addressing, Some of the special function registers are also a bit addressable and bit accessible. Some of them are accumulator, ports and program status word. Okay, and we will see in the timer also, and the timer and the serial communication also we will have some register which are bit addressable. We'll see it later. So coming to the byte level of instructions. So I said the basic Boolean operation that is possible in 8051 is AND, OR, XOR and NOT. So AND instruction, so AND do the logical operation. Okay, logical operation and ANL, accumulator comma #n, ANL, A comma address, ANL, A comma RR, which is nothing but the register. ANL, A comma at the rate of RP. ANL, address comma A. ANL, address comma hash N, immediate data. So coming to the addressing modes, if you see, I am representing the second data as an immediate data here as one of the operand in the register instruction format. So this is immediate addressing mode. Here I am specifying the address of the data as a part of the instruction. So this is direct addressing mode. Here I am specifying the data which is available in the register. This is register addressing mode. And here I am specifying this is a pointer. If I am using at the rate of, this is a pointer where this pointer will point the address of the data. Okay, will point the address of the data. So this is said to be indirect addressing mode. And also here it is address is a part of the instruction, like maybe the destination is address now, and this is an immediate data, so we can say immediate addressing mode, as well as mostly it will be called as immediate addressing mode. You can even call this is address is available, so you can, but it is not the address of the data, okay, it is simply the destination address. So you may even call this as direct addressing mode. So now no flags are affected until and unless, here in the logical instructions none of the flags are affected until and unless you're changing the address of the PSW, meaning for example, if I need to access some of the register banks in RAM, I will be changing the register select bits, right? Register select bits. At that time only your program status word will be affected. Otherwise, it won't be affected. And you are not going to use PSW for storing any data. Okay. So that is how none of the flags will be affected. Okay. And if you look at all the instructions, accumulator will be the part of the instructions. One of the default register is accumulator for the first 4 instructions, first 5 instructions even. Default register is the accumulator. Okay, default register is the accumulator. And the second one is the OR operator. Instead of AN, you will be you have to write ORL. The rest, all the combinations, this combination is same for your ORL also. And the third one is XOR. Okay, and the third one is XOR. Again, XRL instead of ORL, you need to write XRL A comma hash n, XRL A comma address, XRL A comma register, like that. You need to specify the byte level instructions. The next is thing that we need to see is about the bit level instructions. The next thing you need to see is about bit level instructions. So bit level instructions will be operated, as I said earlier, will be operated on the addressed bits. Addressed bits starting from 20 to 2F of your RAM memory, and other than that, your some of the special function register which are bit addressable. Okay. So this is your carry flag. This is your carry flag. So in the bit level logical operation, and is possible, ANL carry comma bit. Okay, bit maybe 00 in the 20th line of your RAM. That is the first line of bit addressable or accessible memory location. The first address bit is 0001 up to 07 you have. If I am specifying ANL, okay, C comma 00H, it means that you are going to operate on this bit position. Okay, so carry flag, if this is 1, carry flag value is 1, if assume that carry flag is 1, and if 00 in the bit position 00, if I have 1, and these two bits, okay, 1.1 is 1 only, okay, and the result will be saved in carry. The result will be saved in carry. So ANL C comma B and ANL C comma slashed bit, meaning what is the slashed bit? I need to take the complement of the bit. If I use the slash, okay, already we know that 00 is having 1. If I am using slashed bit, I need to take the complement of the bit. What is the complement of 1? It is 0. So 1 0 and the result is 0. Save that 0 in the carry flag. That is the meaning of a C comma slashed bit. And ANL C comma, so example I have written C comma 07 is nothing but, for example, if I have 0 here and carry flag is 1, C comma 07 and the carry flag is 1 and 07 is 0, take the complement of 07, so 1 and the result is 1, that will be saved in C. Okay, and then again you have even data transfer instructions, bit level data transfer instructions, move C comma B, C comma B. If for example, if I'm using 00, we know already in 00 we have 1, so move that 1 to the carry flag, move that 1 to the carry flag, move the data that is available in the addressed bit to the carry flag, move B comma C, vice versa is also possible. Okay. C is the carry flag in the PSW, that we know. Carry flag is available in the PSW. ORL is nothing but OR instruction. OR instruction is possible. Bit level logical instruction or operation is possible. ORL C comma B and ORL C comma slashed bit as like as your AND. And then complement your carry bit, complement your addressed bit, clear your carry bit, clear your address bit. Okay, set, similarly your clearing means make it a 0, that is clear. Set B comma carry bit, set B, set bit. What is B in the sense? Set bit. What is the bit? Carry bit. Set bit. What is the bit? The addressed bit. Okay, so this is your bit level logical instruction. And as I said, from 20 to 2F you have bit addressable memory location from 00 to 07 and till 20 to 2F, the last memory location is 7F. So each bit is given an address and each bit we can access. Okay, this is said to be bit addressable memory location. Okay, and keep in mind each line of memory can store only 8 bit of data. Okay, 8 bit out of data, and similarly most of the registers of 8051 are 8 bit registers, and special function register are also given an 8 bit address. Okay, 8 bit address. The address of accumulator is 0 E0. So each bit, so E0 will have from E0 to E7 bit we will be having from 00 to 08. Likewise, program status words address is 0D0. Similarly, each and every bit of every special function register will be given an 8 bit address. So this address will start from, since this will start from 7F, no, it will start from 80. Okay, it will start from 80 to FF is your special function register. Go through your memory mapping. Okay, coming to your rotate and swap instruction. So rotate instruction, in rotate instruction as well as swap instruction, accumulator is one of the default register, is one and only the default register. Okay, you can do all the operations of rotate only through the accumulator. So rotate left accumulator, rotate left through carry accumulator, rotate right accumulator, rotate right through carry accumulator, swap accumulator. Swap in the sense swap your accumulator lower nibble and the upper nibble. Okay, let me take an example. Assume that accumulator has 69H. What is 69H? 0, 1, 1, 0, 1, 0, 0, 1. That is your 69H. What is RRA? Rotate right. Okay, rotate right your accumulator. Okay, rotate right your accumulator by only 1 bit position. 1 bit position. So what is your rotate right? Like this you rotate. You rotate right. See the arrowhead? Like this you are going to rotate. Meaning shifting the position, 1 bit position. And the least significant bit will go to the most significant bit. So what will be the data? Now it will be 1 over here and then shift all other thing. 1, 0, 1, 1, 0, 1, 0, 0. So 1, 0, 1, 1, 0, 1, 0, 0. What is 1, 0, 1, 1? That is B. What is 0, 1, 0, 0? That is 4. Now the accumulator will have D4 in the accumulator. And swap accumulator. So what is the lower nibble? The yellow one, the highlighted one is the lower nibble, 1011, and 0100 is, sorry, this is the higher nibble, this is the lower nibble. So swap in the sense, bring this higher nibble to the lower nibble and lower nibble to the higher nibble. That is your swap. See here, 0100. Now after your swap, it will come here, and 1011, it will come to your 4B. Okay, and clear your carry. Clear your carry. So make your carry flag 0. Check your program status word register as soon as if you execute, after executing your program. Do this in a program using your key and then check. And RRC A, rotate right through carry. Already carry is 0. I made carry 0. So right through carry means involve your carry also. Okay. So meaning from the carry it will go to the most significant bit, and then from here to here, 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 and then go to here, the LSB to the carry. Okay, so here check. So the carry is 1 now. Okay, carry is 1 now, and then from the carry will be moved to the 7th bit position. So it will be 0 0 1 0 0 1 0 1. That is what stored in the accumulator. 0 0 1 0 0 1 0 1. What is 0 0 1 0? It is 2. What is 0 1 0 1? That is 5. So the accumulator will be 25H. Again, rotate left through carry. Okay, rotate left through carry. Okay, and then swap, rotate right through your accumulator. So rotate left through your carry. Again, you need to go ahead with the previous thing. If I do this, it is an inversion operation, right? Earlier, the data is 4B. After rotating right through your carry, I'm sorry, earlier the data available is 4B. After rotating right through your carry, it is 25. If I'm reversing the operation, again rotate left through your carry, what I'll be getting? Again I'll be getting only 4A, because I'm operating the accumulator before executing this instruction. Accumulator is 4B. So I'm reversing the operation. So I'll be getting 4B only here. Then swap it again. If you swap it again, it will be B4 as like this. Okay, it will be before swap you have B4, and then go ahead with RLA again. And the original result as accumulator 69, you will receive it after doing the RLC. Okay, is that fine? So this is about rotate and swap instructions. We will see some more programs in the future classes. Thank you.